Welcome to Lecture 38, in which we're going to consider a word problem. This word problem will continue into Lecture 39, where we will see some, or one of the ways in which ethical considerations might enter into a problem in digital systems. Now, we have some preliminary remarks here. I think that this is actually a fairly simple problem, but please bear with me now while I describe the details. So, as you can see here, we say that we have a vending machine that sells just one item, and the cost of this item is 20 cents. Now, the way that the machine works is that it has 4 slots, and each of these slots will accommodate just one coin. There's one slot for a quarter, one slot for a dime, and there are 2 slots for nickels. And so the first thing we're going to do is to define the Boolean variables Q, D, N1, and N2. And those are defined right here. We'll say that the Boolean variable Q is equal to 0 if the quarter slot is empty when the purchase is attempted, and it's equal to 1 if the quarter slot contains a quarter when the purchase is attempted. Likewise for D, it's 0 if that dime slot is empty when the purchase is attempted, and 1 if the dime slot contains a dime when the purchase is attempted. And similarly for N1, N1 is for nickel slot number 1, and N2 indicates whether or not nickel slot number 2 has a nickel. So I think all of that so far is very obvious. Now, after the customer has inserted his money, he pushes a button. And once he pushes that button, the machine is going to decide whether or not to sell the item to the customer, and also decide how much change the customer deserves. And furthermore, the change will be returned in those same slots. So this is what it says here. Then the same 4 slots are used to return his change. So we're going to now define 5 more Boolean functions. Now these are Boolean functions. These will be functions of the variables that we have already defined. And the functions that we're going to define now are S, RQ, RD, RN1, and RN2, and those functions are defined as follows. S will be 0 if the total inserted money was less than 20 cents. Of course, in that case, since 20 cents is the cost of the item, and if the inserted money is less than 20 cents, then we don't sell the item, and so S is equal to 0. But if the total inserted money is greater than or equal to 20 cents, then S will be equal to 1, because the machine should sell the item in that case. And then we have RQ. This is 0 if the quarter slot is empty after the purchase is attempted, and 1 if the quarter slot contains a quarter after the purchase is attempted. So in other words, another way to think of that is RQ is equal to 0 if no quarter is returned to the customer, and 1 if a quarter is returned to the customer. Likewise, RD is 0 if the dime slot is empty after the purchase is attempted, and 1 if it contains a dime after the purchase is attempted, and RN1 and RN2 are just as you would expect. So everything over here, I mean, it's been maybe a little tedious, but I think everything here is defined in a very natural way, and I hope that everybody follows that. So now, as I noted just above, we note that S, RQ, RD, RN1, and RN2, in other words, the decision of whether or not to sell, and then also the whether or not there's a quarter in the change, whether or not there's a dime in the change, and whether or not there's a nickel in slot N1 in the change, whether or not there's a nickel in slot N2 in the change. All of those are actually functions of what was put in. In other words, Q, D, N1, and N2. So now we finally get to our work in this lecture, and that is to decide what the truth table of each of these functions should look like. So you can see here that here's our truth table, and we have Q, D, N1, and N2. Those are the things that are basically chosen by the customer as to whether or not he puts a coin in each one of those slots. And then depending on the choices that the customer made, we will decide, or the machine will decide, whether or not a sell is made and what change is returned in each slot. So let me get you started on this, and then I'll encourage you to stop the video and try to complete it yourselves to make sure that everybody understands it. So obviously on the first line it's very easy. If the customer does not insert any money, then and that's the case here, because we're saying that in this first case there's no quarters, no dimes, no nickels in slot N1, no nickels in slot N2. So the customer has not put in any money, and therefore it's easy to decide what to do. In this case, there's not an item sold to him, and also no money is returned to him in any of the slots. So S is equal to 0, and so are RQ, RD, RN1, and RN2. Now let's go to the next case. If the customer only puts one nickel in slot N2, then certainly, since he's only inserted 5 cents and the item costs 20 cents, there will not be a sale. So we have a 0 for S. And now we want to, and this is where the ethical considerations will come in Lecture 39, but let's say that we want to, since the customer has put in an insufficient amount of money, we want to return his money to him. So how can we do this? Well, we certainly don't want to give him a quarter, because that would be giving him too much, and we don't want to give him a dime, because that would be giving him too much. But we could now we have a decision to make here, and let's think about this. You think about what you want to do here, and then we'll talk about it together. Okay, you might be inclined to think at first that, well, we have two slots here in which we could return the nickel to the customer, and we don't care which slot is used. We don't care if we return it to the customer in slot N1 or in slot N2, so maybe we should put don't care conditions for both of those. But that would not be appropriate, because if we say that both of these are don't care conditions, then there would be the possibility of returning a nickel in both of them, in which case we would be giving the customer too much change. So we don't want to make this problem too complicated, so let's go ahead and make a decision that in a case like this, we will go ahead and return the nickel in exactly the same slot in which it was inserted. So in this case, we'll put 0 for N1, RN1, and 1 for RN2, since that nickel was inserted in slot N2. And likewise for the next one, again, in this next case, the customer has only inserted a total of 5 cents, so there will be no sale. And we owe the customer 5 cents in change, and we've already said that in a case like this, we'll return the change in the same slot in which it was inserted. And so 0 for RQ, 0 for RD, 1 for RN1, and 0 for RN2. Now, I hope that you will, at this point, stop the video and fill in the rest of this table, and then we'll resume working together. Okay, so now let's see how this would go. Well, in the next case, the customer has now put in nickels in both of the nickel slots, so that's 10 cents, but that's still not enough to get the job done, because the item costs 20 cents. So again, there's still no sale, and we will not return a quarter. Now, of course, we could return a dime, and nothing in either one of the nickel slots. But let's just continue with our procedure, which is that if the customer inserts an insufficient amount of money, we will return his change to him in the same slots in which he inserted it. And so therefore, we'll put a 0 for RD, a 1 for RN1, and a 1 for RN2. And if we stick with that procedure, then the next case is easy as well, because in this case the customer has inserted 1 dime, which is 10 cents. Again, that's insufficient. So we have a 0 for S, a 0 for RQ, 1 for RD, 0 for RN1, 0 for RN2. And the next one, and in fact the next two, again, for both of these cases, the customer has inserted 15 cents, which is still insufficient. So we have 0 for S in both of these cases. And again, keeping with our idea that whenever the customer inserts an insufficient amount of money, the machine should return the money in the same slot in which it was inserted, then we'll have here 0 for RQ in both of those cases, and then 1, 0, 1, and 1, 1, 0. Now we finally get to a case where we will make a sale. If the customer inserts 1 dime and 2 nickels, that's exactly 20 cents, and therefore a sale will be made. And since it was exactly 20 cents, no change should be returned at all, and so each of these will be 0. Now clearly in each of the remaining cases, since we are going to be inserting a quarter in each one of those cases, and the purchase price is 20 cents, we definitely know that in each of the remaining cases a sale will be made. So we can go ahead and set S equal to 1 for all of those cases. And now we just need to decide what change should be returned. Well, in this first case, or the first of these cases under consideration now, we've inserted 25 cents. The item costs 20 cents, so we need to return a nickel. And let's just go ahead and decide now that in a case like this, that we will use N1 before we use N2. So we'll have 0 for quarter. No quarter will be returned. No dime will be returned, but we'll return 1 nickel in slot N1, the first nickel slot, and we won't return anything in the second nickel slot. Now, in the next case, we're inserting 30 cents, 1 quarter, and 1 nickel. So the machine owes back 10 cents, and of course that could be done with either a dime or with 2 nickels. And let's suppose that we'll take a dime. So we have 0 for the quarter slot, 1 for the dime, and 0 for both nickel slots. Same total amount of money here. We have a quarter and a nickel, so 30 cents. And so again, we'll say nothing in the quarter slot on return, but we will have a dime in the dime slot, nothing in either nickel slot. Now for this one, we have a quarter, a dime, and a nickel. So we have 40 cents, and we owe the customer 20 cents. So in this, this is, this is quarter here. Quarter, dime, nickel, nickel. Okay, so I misspoke there. Let's say that again. This is 35 cents because we have a quarter but no dime, and we have both nickels. So a quarter and 2 nickels, 35 cents. We owe the customer the item, and we also owe the customer 15 cents in change. And so we'll go 0 for quarter, one for dime, and we'll put that nickel in the nickel slot 1. In this case, same total amount of money, 35 cents again, because we have a quarter and a dime. So the same thing over here, 0 in the quarter slot, 1 in the dime slot, and 1 in nickel slot number 1. In this case, we have a quarter, a dime, and a nickel. And a quarter, and a dime, and a nickel is 40 cents. The item costs 20 cents, so we owe the customer 20 cents. And there's only one way we can do that, and that's 0 for the quarter slot, and 1 in the dime slot, and 1 in each nickel slot. This is the same amount of money here, a quarter, a dime, and a nickel. So we'll do the same thing over here, 0, 1, 1, 1. And then finally, in this case, we have a quarter, a dime, and 2 nickels. The dime and 2 nickels is sufficient to purchase the item. And so in this case, we can return the quarter, and we don't return anything else. Now again, I want to make sure you understand these choices that were made here were, in some cases they were unique choices, but in some cases we had some options. But we're just supposing that the way that I filled in the table here is the way that the machine was designed. So this would be the truth table representing the functions S, RQ, RD, RN1, and RN2 as functions of Q, D, N1, and N2. And now what we're going to do for our test questions is to find functional expressions for some of these functions, and then to give you a look ahead in lecture 39, which will be our final lecture. We're going to see what would change if we were willing to make the decision that when the customer did things that really aren't very smart, like for instance here, putting in just a nickel and nothing else, well, perhaps we don't even want to return that nickel in that case, since that was not a very smart thing to do. Or, perhaps we could put a sign on the machine and say, be sure to insert at least 20 cents or you will not receive any change. Now you might think that that's a harsh thing to do, or an unfair thing to do. Perhaps the customer is unable to read, and so maybe that's an unfair thing to do. But we'll see that what some of the consequences of that kind of decision would be. But for right now, we're not going to worry about anything like that. We're doing everything completely on the up and up here, and we're always returning the correct amount of change to the customer regardless of what he does. And so now that we have filled in the truth table for each of these functions, let's get to our test and find expressions for some of these functions. On second thought, let me do one of these for you just to make sure that the question is clear, and then I'll ask about some other questions in the test. So let's have this as an example question. Let's say find a minimal, well, in fact, let's say all. Find all minimal sum expressions for, let's say, Rn1 as a function of Q, D, N1, and N2. So we have here a function of 4 Boolean variables, And so we know that in this case, we're going to have a Karnaugh map that looks like this. And we'll put Q and D on the vertical axis, and N1 and N2 on the horizontal axis. And remember the way that we label these: 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And now we need to look at the Karnaugh map for, remember we're looking here for RN1. So we come up here and we see that we're looking here at the next to last column in this table. So for the first four numbers here, which is, notice the first four represent Q and D are both equal to 0. So that means it's going to be this top row of the Karnaugh map. And we have 0, 0, 1, and 1. And let's be careful of how we fill that in. That's 0, 0, 1, 1. Now let's look at the next four numbers. We have 0, 0, 1, 0. So we'll come down here, 0, 0, 1, 0. Now, make sure you understand why the 1 goes here rather than in this square. This 1 corresponds to the situation Q and D are 0, 1, N1 and N2 are 1, 0. Now let's come and see if that's correct. Q and D 0, 1, N1 and N2 are 1, 0. So we did indeed put this 1 in the correct location. So we've done 1, 2, 3, 4, 5, 6, 7, 8. We've done the first 8, and now let's do the next 8. 1, 0, 0, 1. It's okay, so we come down here, and remember we need to come to the bottom. 1, 0, 0, 1. And you can see that this is the correct row, because this is when we have 1 for Q and a 0 for D, which is indeed what we're having there. 1 for Q, 0 for D, and you had 1, 0, 0, 1. And notice this 1 here is in 1, 0, 1, 1, and sure enough, 1, 0, 1, 1, here's the 1. Okay, and now for the final four entries, we come down here, 1, 1, 1, 0, 1, 1, 1, 0. So this completes the Karnaugh map. Again, this is for RN1. And now we're ready to find all minimal sum expressions for Rn1 as a function of Q, D, N1, and N2. So let's proceed with this. Remember that if we want minimal sums, then we're going to be looking for prime implicants. And we have no rectangular groupings of 16 one cells for sure. No rectangular groupings of 8 one cells. What about rectangular groupings of 4 one cells? Well, it doesn't look like it to me. It's close in some spots, but not quite there. So we're going to have to look for rectangular groupings of 2 one cells, and let's see about that. Starting with the ones that are not so easy to see, we have this grouping of 2 one cells there, and in fact I definitely hope now that you'll stop the video at this point and try to complete this on your own. because this is something you definitely need to know. So, now, if for that prime implicant, let's figure out what its name is. Well, Q and D are both constant equal to 1, so we have Q, D. And notice that N1 is changing, but N2 is constant and equal to 0, so we have N2 prime. Now, another prime implicant of size 2 that would be easy to miss is this one. And for that one, we notice that Q is changing, so it does not appear in the name of the prime implicant. D is constant equal to 0, so we have D prime. And N1 and N2 are both constant and equal to 1, so we have N1, N2. Now, I don't see any other prime implicants of size 2 that are tricky to find, so let's do the ones that are easy to find. One would be this one, and there Q and D are constant equal to 0, so we have Q prime, D prime, and notice that N2 is changing, so we don't include it in the name, but N1 is constant equal to 1, so we have N1. Another one that's easy, another prime implicant that's easy to find is this one. And Q is changing, Q is constant equal to 0, so we have Q prime. D is changing, so it does not appear in the name. N1 is constant equal to 1, so we have N1. And N2 is constant equal to 0, so we have N2 prime. Another prime implicant of size 2 is this one. And here Q is changing, so it does not appear in the name, but D is constant equal to 1, so we have D. And N1 is constant equal to 1, so we have N1. N2 is constant equal to 0, so we have N2 prime. And now another grouping of size 2 is over here on the left-hand side. Q is constant equal to 1, so we have Q. D is changing, so it does not appear in the name. N1 and N2 are constant equal to 0, so we have N1 prime. N2 prime. And then one final grouping here of size 2 is right there. And that will be Q, D, N1 prime. And I don't believe that there are any other groupings of size 2, and there are no, so then we go to groupings of size 1, and there are no groupings of size 1 that are not entirely contained within a prime implicant that we've already identified, and therefore we're done. So now we want to see if there are any essential prime implicants. So you will recall that the way we do this is by looking for essential one cells. So let's go through and identify those, starting on the top row. This one is contained within more than one prime implicant, so it's not essential. The same is true for this one. The same is true for this one. The same is true for this one. So none of these one cells is an essential one cell. What about this? This is contained within more than one prime implicant, so it's not essential either. However, this one is contained within only one prime implicant, so this one cell is essential, and likewise this one cell is essential, and this one cell is essential. So we conclude then that the prime implicants that are essential, okay, let's come over, let's take care of this one first. This one cell is in the prime implicant right here, QDN1 prime. QDN1 prime. This one cell is in this prime implicant, QN1 prime and 2 prime. QN1 prime and 2 prime. And finally, this one cell is in this prime implicant right here, which is D prime N1 and 2. D prime N1 N2. So those 3 prime implicants are the essential prime implicants for this problem. And now we're ready to finish. We're going to have all minimal sums. And so we have Rn1 is equal to, and remember that we always start with what's essential. So we'll have QD N1 prime or Q N1 prime N2 prime or D prime N1 N2. So we start with that, and now we need to go up to our Karnaugh map and shade in those terms because we've accounted for those, and then we'll see what else we need to include. So the QDN1 prime, as you can see right here, that's this term, so we can shade in this QDN1 prime. We've taken care of those two terms. QN1 prime and 2 prime is right here. So we've also taken care of this. And then D prime N1 and 2 is right here. D prime N1 and 2. So we've taken care of this and this term. So clearly we have not quite finished what we need to do here because we have 3 more one terms or one cells that need to be accounted for before we'll have everything necessary for Rn1. And let's ask ourselves, well, how can we do this? Well, there's no way we can include all 3 of those with the addition of just one more term. We're going to have to add at least 2 more terms. But there's more than one way that we can do that by adding just 2 terms. So we're going to have more than one minimal sum here. So let's go ahead and prepare ourselves for at least one additional minimal sum. Now remember, every one of them must contain all of the essential prime implicants. So we'll go ahead and put those in. And now let's see if 2 will be enough. Okay, so one obvious way in which we could finish up this problem is to include this prime implicant for these two, and then the prime implicant containing these two. So in other words, we could include Q prime D prime in 1, Q prime D prime in 1. That would be this prime implicant. And then if we do that, then of course that would take care of this 1. And then we could account for the remaining 2 1s by including D in 1 and 2 prime. D in 1 in 2 prime. But clearly, another way that we could include these 3 1s would be by using this prime implicant that goes here and there. So that is this one, QD in 2 prime, QD in 2 prime. But if we use that to account for this one, then we're going to have to use this one right here because we want to get the remaining ones in just one more term. So we would have this one, Q prime in 1 in 2 prime. Q prime in 1 in 2 prime. Either one of these options, either one, this option right here or this option right here, either one will account for these 3 extra 1 cells. But any other way of doing that is going to have to require more than just 2 additional terms. So we conclude that there are just 2 minimal sums for Rn1, and they are the 2 minimal sums shown here. So that's how you would do that problem, and now we are ready for our test problems. So now for our test questions. The first one asks find all minimal sums for S as a function of Q, D, N1, and N2. And your choices are A, S equals Q plus D, N1, N2. B, S equals Q or Q prime D N1 N2. C, S equals 0. D, S equals 1. 38.2, find all minimal sums for RD as a function of Q, D, N1, and N2. And each of the choices has multiple minimal sums, so be careful. On A, there's actually 3 minimal sums listed. And let me read all these to make sure you can read everything here. So in A, you have the first minimal sum is RD equals DN1 or DN2. Excuse me, let me start over, sorry. The first minimal sum is RD equals DN1 prime or DN2 prime or QN1 prime N2 or QD prime N1. The second minimal sum is RD equals DN1 prime or DN2 prime or QN1 N2 prime or QD prime N2. And the third minimal sum is RD equals DN1 prime or DN2 prime or QD prime N1 or QD prime N2. That's A. For B, for B, C, and D, we have two minimal sums for each of these. For B, the two minimal sums are RD equals DN1 prime plus DN2 prime plus QN1 prime N2 plus QD prime N1. And the second one is RD equals DN1 prime plus DN2 prime plus QN1 N2 prime plus QD prime N2. In C, the two minimal sums are RD equals DN1 prime plus DN2 prime plus QN1 prime N2 plus QD prime N1. And the second one is RD equals DN1 prime plus DN2 prime plus QD prime N1 plus QD prime N2. And finally, in D, the two minimal sums, the first one is RD equals DN1 prime plus DN2 prime plus QN1 N2 prime plus QD prime N2. And the second one is RD equals DN1 prime plus DN2 prime plus QD prime N1 plus QD prime N2. And then the third one will be given in class. And again, of course, you'll, in order to answer these two questions, you'll want to refer to this table that we did in the lecture. So that's it, and good luck.